Hello viewers, in today's lecture we are going to take up an important concept in three-dimensional geometry, that is the concept of direction cosines and direction ratios. Viewers, let us suppose that we have a line, say this is a line, right? And suppose this line makes angle alpha, beta and gamma with x, y and z axis. So for showing the angles made by this line with the axis, let us draw a vector parallel to this line, right? So this is the vector, and here say we have point P, and it has coordinates x, y and z, right? Now this line L is parallel to OP. Clear? So uh, we'll we will consider the angles made by this vector with the positive direction of the axis. Now with uh, x-axis, let us say this angle is alpha, and with y-axis let us say this angle is beta, and with z-axis let us say this angle is gamma, right? Then these angles alpha, beta and gamma, which this line makes with the positive direction of these three axes, are called the direction angles, right? And the cosine of these angles, that is cos alpha, cos beta and cos gamma, are called the direction cosines, which is denoted as DCs, means direction cosines of the directed line. So the direction cosines of this line L are denoted by L, M and N. L is cos alpha, M is cos beta and N is cos gamma, right? So this line makes angles alpha, beta and gamma with the positive direction of these axes, right? And the cosine of these angles, that is cos alpha, cos beta and cos gamma, are called the direction cosines of the directed line L, right? Here we have shown two directions because a line can be extended in two directions, but if we take this direction, then the direction cosines will be cos of pi minus alpha, cos of pi minus beta and cos of pi minus gamma, right? So here we are taking this direction because our vector OP is in the same direction. So this vector OP makes angles alpha, beta and gamma with these with the positive direction of the three axes. So the cosine of these angles is known as the direction cosines of this directed line L, right? And the DCs in short are denoted by the letters L, M and N, right? For example, suppose we have a line in space which makes an angle of say 90 degree, 135 degree and 45 degree with the positive direction of x, y and z axis, then what will be the direction cosines of that line? So the direction cosines are given by L equal to cos alpha, M equal to cos beta and N equal to cos gamma. So here alpha is 90 degree, this is beta, and this is gamma, right? So the direction cosines of this line will be L equal to cos of 90 degree, and then M is cos of beta, which is 135 degree, and then we have cos of 45 degree, right? So cos 90 is 0, and cos of 135 is minus 1 over root 2, and cos 45 is 1 over root 2. So therefore the direction cosines which are denoted by this symbol L, M and N, so these are 0, we have minus 1 over square root of 2, and then we have 1 over root 2. So these are the direction cosines of this line, right? Now viewers, let us take this problem. If a line makes angle alpha, angle 90 degree, 60 degree and 30 degree with the positive direction of x, y and z axis respectively, find its direction cosines. So here we know that if the angle make alpha, beta and gamma angles with the positive direction of the axis, then the DCs, the direction cosines, are given by L, M and N. So here we are given alpha is 90 degree, beta is 60 degree and gamma is 30 degree, right? So L is cos alpha, so cos alpha is cos of 90 degree, that is 0, and then we have M, which is cos of beta, that is cos of 60 degrees, which is half, and then we have N, that is cos of gamma, that is cos of 30 degrees, right, which is equal to square root of 3 divided by 2. Clear? So therefore the direction cosines are given by these are given by 0, half and square root of 3 divided by 2, right? So this is how we solve the problems of finding out the direction cosines of a line, right? Now viewers, let us take these three important problems. Here we have to find the direction cosines of x-axis, then find the direction cosines of y-axis, and then find the direction cosines of z-axis, right? So we know that this x-axis makes an angle of 0 degree with itself, 90 degree with y-axis, and 90 degree with z-axis, right? We have to find the direction cosines of x-axis. So what are direction cosines? Direction cosines are the cosines of the angle made by that line with the axis, and here we have to find the direction cosines of x-axis. So we know that x-axis makes an angle of 0 degree with itself and 90 degree with y-axis and 90 degree with z-axis, right? So the direction cosines are L is equal to cos of 0, M is equal to cos of 90 degree, and N is equal to cos of 90 degree, right? So cos 0 is 1, cos 90 is 0, cos 90 is 0. So the direction cosines of x-axis are 1, 0 and 0, right? Now here we have to find the direction cosines of y-axis. So alpha is 90 degree, because y-axis makes an angle of 90 degree with x-axis. Now beta is 0 degree, because y-axis makes an angle of 0 degree with itself, and gamma is 90 degree, because the angle between y and z axis is 90 degree. So therefore L is 0, M is 1 here, because cos of 0 is 1, and N is 0. Now similarly find the direction cosines of z axis. So here alpha is 90 degree, beta is 90 degree, and gamma is 0 degrees, right? Because z axis makes 0 degree with itself. So L is 0, M is 0, and N is 1, right? So therefore viewers, we must remember that the direction cosines of x-axis are 1, 0, 0, y-axis are 0, 1, 0, and z-axis are 0, 0, and 1. Now viewers, let us move further. Here we have the vector OP. See, the vector OP is given by xi cap plus yj cap plus zk cap, right? And let us say this OP is vector r, right? And the magnitude of this vector OP is denoted by, say, simply r, and it is square root of x square plus y square plus square root of x square plus y square plus z square, right? Now viewers, here I am going to tell you one very important property of direction cosines, right? So the property is that we know that L is equal to cos alpha. Now this cos alpha can be written as x divided by the magnitude of this vector r, right? So L can be written as x over r. Similarly, M, that is cos of beta, can be written as y over r, right? And N can be written as cos of gamma, that is z over r. Now always remember that L, M, N are direction cosines. L is equal to cos alpha, M is cos beta, N is cos gamma. Now the direction cosines can also be expressed as x over r, then cos beta is y over r, and cos gamma is z over r, right? Now from here we see that x can be written as LR, right? LR. Y is equal to MR, and Z is equal to NR. Clear? Okay. Now if we substitute these values, or if we square and add these three equations, right? So if we write x square plus y square plus z square, then we have LR square plus MR square and NR square, right? Okay. Now x square, from here we see that r square is equal to x square plus y square plus z square. Now this x square plus y square plus z square can be replaced by r square here. So r square is equal to, here we have L square, r square, m square, r square plus n square r square. Now r square is equal to, we take r square common, so we have r square times l square plus m square plus n square, and r square get cancelled, and we have an important result, that is l square plus m square plus n square is equal to 1. R square and r square get cancelled and gives us 1. So always remember that l square plus m square plus n square equal to 1. It means the sum of the squares of the direction cosines of a line is equal to 1, right? Suppose if we substitute these values here, then we can write this statement as cos square alpha plus cos square beta plus cos square gamma is equal to 1, right? So this is a very important result. So the sum of the squares of the direction cosines of a line is equal to 1, and cos square alpha plus cos square beta plus sin square gamma is equal to 1, right? Now viewers, we have derived these results. Now let us derive one more very important result. We have cos square alpha plus cos square beta plus cos square gamma is equal to 1. So from trigonometry we know that cos square theta is equal to 1 minus sin square theta, right? So let us apply this rule to this equation. So cos square alpha can be written as 1 minus sin square alpha, then we have 1 minus sin square beta, then we have 1 minus sin square gamma is equal to 1, right? Now we have 1 plus 1 plus 1, that is 3, and we have minus of sin square alpha plus sin square beta plus sin square gamma is equal to 1, right? Now if we arrange this, we get sin square alpha plus sin square beta plus sin square gamma is equal to 3 minus 1, that is 2, right? So always remember this rule also. So what we have discussed? So we have discussed that the sum of the squares of direction cosines of a line is equal to 1, right? Now viewers, let us come to the concept of direction ratios. Now the definition of direction ratios is any three numbers which are proportional to the direction cosines of a line are called the direction ratios of the line. We have just read that the direction cosines are denoted by L, M and N, and L is equal to cos alpha, M is equal to cos beta, and this is cos gamma, right? And moreover, L is equal to x over r, M is equal to y over r, and N is equal to z over r, where r vector is xi plus yj plus zk, right? And r square is x square plus y square plus z square, right? Okay, so what are direction ratios of a line? So the direction ratios of a line are any three numbers which are proportional to the direction cosines. So let A, B, C, A, B and C denote the direction ratios of this line L, right? Of this line L, of the line L. So therefore we have the result, that is, as per this definition, any three numbers which are proportional to the direction cosines. So it means A is equal to lambda L, B is equal to lambda M, and C is equal to lambda N, right? So A, B, C, here A, B, C are called the direction ratios, and these direction ratios are proportional to the direction cosines, and lambda is a constant. Lambda is a non-zero constant. This is non-zero real number, right? Non-zero real number, and L, M, N are given by these expressions, right? Okay, so here what we have discussed, L, M, N are called the direction cosines, and these are given by these equations, and A, B, C are called the direction ratios, and these A, B, C are given by these equations, right? Now this is the relationship between direction ratios and direction cosines. Now from here, see, lambda or we can write A by L is equal to lambda. Similarly, B by M is equal to lambda, and C by N is equal to lambda, right? Okay, now viewers, let us find a relationship between the direction cosines and direction ratios. Now here from these equations, let us square these equations and then add up. That is, let us find a square plus b square plus c square. So we have lambda L square, then we have lambda M square, and then we have lambda N square, right? So where's this is a square plus b square plus c square, then we have lambda square L square, lambda square M square, and lambda square N square. So this can be written as a square plus b square plus c square. Then we have lambda square, and we take lambda square common, so we have L square plus M square plus N square. Now we know that the sum of the squares of direction ratios is equal to 1, so L square plus M square plus N square is 1. So if we substitute here 1, we have a square plus b square plus c square is equal to lambda square times 1, that is lambda square, or lambda can be written as square root of a square plus b square plus c square, right? Now if we substitute this value of lambda in these three equations, then see what we will get, right? So here we'll get from this equation, we have I'm writing it here, see, a by L is equal to lambda, so L can be written as a over lambda, right? We take L to this side and then taking lambda to the denominator, so we have L is equal to a over lambda. Now if we substitute the value of lambda here, so we get a over square root of a square plus b square plus c square, right? Similarly, b or m is equal to lambda, it is b over lambda, so we have b divided by square root of a square plus b square plus c square, right? And then n can be written as c over lambda, then we have c divided by square root of a square plus b square plus c square, right? So these are the very important result which connects the direction cosines and direction ratios. Now viewers, let us take another important topic, that is direction cosines of a line passing through 2 points. Now here we have a line and we have 2 points. This line passes through 2 points x1 y1 z1 and x2 y2 z2, right? And we have to find the direction cosines of this line. So the direction cosines are given by L, M and N. Now L can be calculated by this rule, that is x2 minus x1. We will find the difference between the x coordinates and then we will divide it by the magnitude of AB, that is here we have AB, then M can be written as y2 minus y1 divided by AB, and then we have N, that is z2 minus z1 divided by AB, right? So these are the rules for finding out the direction cosines of a line passing through 2 points. So here the line is L. Now here let us first find the magnitude of vector AB, right? So this is AB, and AB is square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, right? So AB is x2 minus x1 means 1 minus minus plus, so we have 3 square, then we have minus 2 square, and then we have 8 square, right? So this is 9 plus 4 plus 64, and this is equal to square root of 77, right? So here's now the direction cosines are x2 minus x1, so x2 minus x1 is 3, so we have 3 over square root of 77, then y2 minus y1, that is minus 2 divided by square root of 77, and then we have z2 minus z1, that is 8, and divided by square root of 77, right? So the direction cosines of a line passing through 2 points x1 y1 z1 and x2 y2 z2 can be calculated by this formula, and for this example here the direction cosines are 3 by square root of 77 minus 2 by square root of 77 and 8 by square root of 77, right? Now viewers, let us find the direction ratios, right? In the previous article we have discussed the direction cosines. Now we are discussing the direction ratios of a line passing through 2 points, right? So here again I am taking the same example. So the direction ratios of a line passing through 2 points x1 y1 z1 and x2 y2 z2 are given by A, B and C, and the direction ratios are x2 minus x1, y2 minus y1 and z2 minus z1, right? So here x2 minus x1 is 1 minus minus 2, this is 2 minus 4, and z2 minus z1 is 3 minus minus 5. So this is 1 plus 2, that is 3, this is minus 2, and this is 8, right? So the direction ratios of this line passing through these 2 points is 3 minus 2 and 8, right? While the direction cosines of this line, as we have just calculated in our previous example, are 3 divided by square root of 77 minus 2 divided by square root of 77 and 8 divided by square root of 77. Now viewers, let us take this problem. If a line has the direction ratios minus 18, 12 and minus 4, then what are its direction cosines, right? So here we are given the direction ratios, and A, B, C are the direction ratios. So we are given A equal to minus 18, B equal to 12 and C equal to minus 12, and we have to find the direction cosines. Now in our discussion we have seen that the relation between direction cosines and direction ratios is L is equal to A over square root of A square plus B square plus C square, then M is B over square root of A square plus B square plus C square, and N is C divided by A square plus B square plus C square, right? Now let us first find this term, that is square root of A square plus B square plus C square. So we have minus 18 square, then we have 12 square, and then we have minus 4 square, right? Now square root of minus 18 square plus 12 square plus minus 4 square is square root of 484, that is 22, right? So here's L becomes A over this term, and this is 22. So we have minus 18 divided by 22, M is 12 divided by 22, and N is minus 4 divided by 22. And now if we simplify it, then we have minus 9 by 11, M is 6 by 11, and N is minus 2 by 11. So therefore the direction cosines of this line are minus 9 by 11, 6 by 11 and minus 2 by 11. Now viewers, let us take again a same type of problem. If a line has the direction ratios 2, minus 1 and minus 2, then what are its direction cosines? So here we are given A equal to 2, B equal to minus 1 and C equal to minus 2. Viewers, always remember, direction ratios, we are denoting direction ratios by A, B, C, while the direction cosines are denoted by L, M and N. Now L is A over square root of A square plus B square plus C square, then M is B divided by square root of A square plus B square plus C square, and N is C divided by we have here square root of A square plus B square plus C square. Now let us find square root of a square plus b square plus c square. So we have 2 square plus minus 1 square, and then we have minus 2 square. So this is 4 plus 1 plus 4, this is 9, square root of 9, that is 3. So therefore L is a divided by 3. So a is 2 by 3, m is minus 1 by 3, and n is minus 2 by 3. Right? Now viewers, let us apply the concept of direction ratios for proving the collinearity of 3 points. We know various methods for proving the collinearity of 3 points. So here we are applying the concept of direction ratios. So here we have to show that these 3 points are collinear, right? So we have denoted these points by the letter A, B and C, and we have to show that these 3 points are collinear. So what we will do, we will first find the DRs of AB, right? DRs of AB, and DRs of AB are C. This is x1 y1 z1, this is x2 y2 z2, this is x3 y3 z3. So whenever we find the DRs of a line passing through 2 points, then DRs are C, x2 minus x1, y2 minus y1, and z2 minus z1. So this is the general formula. So here the DRs of AB are minus 1 and minus 2, then we have minus 2, minus 3, and then we have minus 1 and minus 4, right? So x2 minus x1, then we have y2 minus y1 and z2 minus z1. So these are minus 3, minus 5 and minus 5, right? Okay, now we find the DRs of BC, right? So again we will use this formula. Now we have 5 minus minus 1, then we have 8 minus minus 2, then we have 7 minus minus 1. So we have here that is 6, and then we have 10, then we have 8, right? This is 7 minus C, it is minus 1 minus 2. Here we have viewers, you are requested to correct it. Here we have only 1, right? Here we have 1. So it is by mistake I have written here minus 1. So please correct it. Here we have 1. So we have here we have 1 minus 4, that is minus 3, right? This is minus 3. And now here we have 7 minus 1, and this is 6, right? Okay, so the DRs of AB are minus 3, minus 5, minus 3, and DRs of PC are 6, 10 and 6. And we see that these two direction ratios of AB and BC are proportional. These are proportional. How they are proportional? Because see, minus 3 by 6 is equal to minus 5 by 10 is equal to minus 3 by 6. They are all equal to half, minus half, right? So these two direction ratios are proportional, and hence we declare that AB is parallel to BC, AB is parallel to BC, but point B is common. B is common to both AB and BC. Therefore A, B and C are collinear, right? So viewers, this is how we prove the collinearity of 3 points. Now viewers, let us take this problem. Find the DRs of the sides of the triangle whose vertices are given by these points. So here we have the triangle and we have to find the DRs of the sides of the triangle. So DRs of AB, DRs of this side AB are calculated by, we know the rule, if we have a line which passes through 2 points x1, y1, z1 and x2, y2, z2, then the direction ratios are given by x2 minus x1, y2 minus y1 and z2 minus z1. So we will apply this rule to all the 3 sides. So DRs of AB are 3 minus 1, then we have 5 minus 1, and then we have minus 4 and minus 2, right? So the DRs are, here we have 4, then we have 4, then we have minus 6, right? Now DRs of BC are, this side BC are minus 5, x2 minus x1, so we have minus 5 and minus 1, then we have y2 minus y1, so we have minus 5 and minus 1, then we have minus 2 and minus 2. So this is plus, so we have here minus 4, then we have minus 6, then we have minus 4, right? Now DRs of AC are again x2 minus x1, so we have 3 minus minus 5, then we have 5 minus minus 5, and then we have minus 4 minus minus 2, right? So this is equal to 8, then we have 10 here, and here we have minus 2. So these are the direction ratios of the 3 sides. Now viewers, let us take this important problem. Find the direction ratios and direction cosines of the vector I cap plus 2j cap plus 3k cap. So viewers, always remember that the direction ratios of a vector, suppose this is a vector A and we have the x component, and suppose if we compare this vector with xi plus yj plus zk, then we see that x is 1, y is 2 and z is equal to 3, right? Now the magnitude of this vector is square root of x square plus y square plus z square. So we have 1 square plus 2 square plus 3 square, and this is square root of 14. Now the first thing, after doing all these things, now we have to find the DRs and DCs of the vector. Now always remember the DRs of a vector are its x, y and z components itself, right? So therefore DRs of A, vector A are 1, 2 and 3. These are the DRs, and the DCs of of this vector are x by the mod of or the magnitude of this vector a, y by a, and z by a. So these are x is 1, so 1 over square root of 14. Then we have 2 over square root of 14, and then we have 3 over square root of 14, right? So here the dr's of a vector are the x, y, and z components itself, right? But the dc's are obtained by dividing the dr's by the magnitude of vector A. Clear? Now suppose we have a vector, say vector is vector I cap plus j cap. Now we have to find its direction ratios. So we can express this vector as I cap plus j cap plus here we have 1, here we have 1, and here we have 0, k cap. So what are the dr's? So dr's are 1, 1, and 0. And what are the dc's? Now first of all, find out this term, that is 1 square, square root of 1 square plus 1 square plus 0 square, and this is the square root of 2. So dc's are obtained by dividing these three numbers by square root of 2. So the dc's are 1 over square root 2, 1 over square root 2, and 0 over square root 2. And this can be written as 1 over square root 2, 1 over square root 2, and here we have 0, right? Now viewers, let us take this important problem. Here we have to find the dr's and dc's of the x, y, and z axis, right? So our axes are shown here, and we have to find the dr's and dc's of these axes. Now we know that the dc's are for x-axis, dc's of x-axis are 1, 0, and 0, right? Similarly, dc's of y-axis are 0, 1, 0, right? And dc's of z-axis are 0, 0, and 1. So always remember that dc's of x-axis are 1, 0, 0, dc's of y-axis are 0, 1, 0, and dc's of z-axis are 0, 0, 1. Now what are the dr's? Now see, let us first find the dr's of x-axis. Clear? Now for x-axis the dc's are L is 1, M is 0, and N is 0, right? Now viewers, here we have L is 1 because we have cos 0 degree here, and for M equal to 0 we have cos 90 degrees, and here we have cos 90 degrees, right? So this is how we find the direction cosines of x-axis, right? Because x-axis makes angle 0 degree with itself, and 90 degree with y-axis, and 90 degree with z-axis. Now our aim is to find the direction ratios of x-axis. Now viewers, always remember that any vector which is parallel to or which is along x-axis is of the form, say if we take a vector A which is along x-axis, then it is of the form, say, lambda I cap, right? And this vector does not have any y or z component. Clear? So we can write it like this: 0 j cap and 0 k cap. Clear? So I am once again repeating, because the concept of direction ratios of x-axis, y-axis and z-axis is very important. So I am repeating, any vector which is along x-axis can be expressed in the form lambda I cap plus 0 j cap plus 0 k cap. Clear? Or simply we leave this, so we have lambda I cap. Now lambda is any real number, right? So the direction ratios of x-axis are lambda 0 and 0. Clear? If lambda is 1, then the direction ratios are 1 0 0, and if lambda is, say, 2, then the direction ratios are 2 0 and 0, right? Now similarly, for finding out the DRs of y-axis, we have L is 0, M is 1 and N is 0, right? And how? Because y-axis makes a 90-degree angle with x-axis and 0 degree with itself and 90 degree with z-axis, right? Now again we will follow the same explanation. If we take any vector along y-axis, say vector b, then vector b can be represented as lambda j cap. Clear? And here we have 0 I cap, 0 I cap plus 0 k cap, right? Or we simply write it as lambda j cap. Now this lambda again belongs to real number, so the direction ratios of y-axis are 0 0 lambda 0, 0 lambda 0. Again, if lambda is, say, 1, then the direction ratios are 0 1 and 0, right? If lambda is, say, 5, then the direction ratios are 0 5 and 0. Clear? Now we have to find the DRs of z-axis. So let us take a vector along z-axis, say vector c, and we know that L is 0, M is 0 and N is 1. The direction cosines of z-axis are 0 0 and 1. Why? Because z-axis makes angle of 90 degree with x-axis, 90 degree with y-axis and 0 degree with itself, right? Now this vector c can be represented as lambda of say k cap, and this can be written as 0 I cap, then we have 0 j cap, and then we have lambda k cap. So therefore the DRs of z-axis are 0 0 and lambda. Clear? And lambda again belongs to the set of real numbers. So if lambda is 1, then the DRs are 0 0 1. If lambda is 2, then the DRs are 0 0 and 2. Clear? So here we have taken vector A along x-axis, vector B along y-axis, and vector C along z-axis. Clear? So what we are saying? We are saying that the dr's of vector A, the dr's of vector A are lambda 0 and 0. Clear? And the dr's of vector B are 0, lambda 0, and the dr's of vector C are 0, 0, and lambda, where lambda belongs to the set of real numbers, and as we take different values of lambda, then the dr's of the vectors A, B, and C keeps changing, right? But in all cases, the direction cosines of x-axis, y-axis, and z-axis remains the same. That is, the direction cosines of x-axis are 1, 0, 0, and the direction cosines of y-axis are 0, 1, 0, and direction cosines of z-axis are 0, 0, and 1. Now viewers, let us take this important problem. Find the direction cosines of a line which makes equal angles with the coordinate axis, right? So let us take a line, say if this line passes through the origin, suppose this is the line, right? Now this line makes equal angles with the coordinate axis, and suppose this line makes angle alpha with x-axis, beta with y-axis, and gamma with z-axis. Now here we are given that this line makes equal angles with the coordinate axis. So alpha is equal to beta is equal to gamma. Now we have L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma, right? Now here we have cos beta, so beta is equal to alpha, so we can write cos alpha. Gamma is equal to alpha, so we can write cos alpha. Now L, M, and N, all the three the direction cosines are equal, right? So here we see that L is equal to M is equal to N is equal to cos alpha, right? Now we know that the sum of the squares of the direction cosines is equal to 1. So we have cos square alpha plus cos square alpha. Here again we have alpha. Then we have cos square alpha equal to 1, right? So 3 cos square alpha is equal to 1. Clear? Now we can have cos square alpha is equal to 1 by 3. So cos alpha is 1 over square root of 3. Clear? Now we have L is equal to cos alpha, so we have plus minus 1 over square root of 3. M is again cos alpha, so we have plus minus 1 over square root of 3. And then we have N that is equal to cos alpha, that is 1 over square root of 3. Clear? So these are the direction cosines of a line which makes equal angles, with the coordinate axis.